Hello guys and welcome to Mossy Maths, and today we're going through Mathematics B Unit 1 Statistics and Probability, and we're allowed a calculator for this exam. We're going through the Pearson Edexcel GCSE May 2015 paper, and I'm just going to go through the full paper and you can follow exactly what I'm doing, and hopefully this will give you an idea of how to attempt questions in future papers. Now let's get started with question 1. Millie has a biased coin. When she throws the coin once, the probability of getting heads is 0.2. Part A, write down the probability of getting tails. Now, this question is testing our understanding on how we work out probabilities, and hopefully we should know that all probabilities add up to 1. So if we throw a coin, we can get either heads or tails. And so if the probability of getting heads is 0.2, then the probability of getting tails is the rest of the probability that goes up to 1. So, in other words, 1 minus 0.2 will give us the probability of tails, which is, of course, 0.8. Okay? Now the next part says Millie throws the coin 200 times, and we're told to work out an estimate for the number of times she gets heads. Now, the way we do this is we look at part A, where we're told that the probability of getting heads is 0.2. So if the coin is being thrown 200 times, then the probability of it landing on heads in that 200 times is simply 200 times 0.2. And we're allowed a calculator, so we can just type that in and we get 40 times, okay? So hopefully that's relatively straightforward. Okay guys, so now let's look at question 2. Bill wants to compare the heights of pine trees growing in the sandy soil with the heights of pine trees growing in clay soil. The scatter diagram gives some information about the heights and the ages of some pine trees. So here's a diagram, and part A says describe the relationship between the height of the pine trees and the age of the pine trees growing in the sandy soil. So the sandy soil is given to us with this key. It's the line with the X's, okay? So it's this line here we're looking at, and the relationship is simply as one increases, so does the other. As height increases, so does the age in years. So does the age of the pine trees. Okay? And we can add to this. This is a positive correlation, okay? The correlation is positive. In other words, it's a positive gradient straight line. As one increases, so does the other. So for part B, a pine tree is growing in clay soil and it's 18 years old. Find an estimate for the height of this tree. Okay, so all we do here is we find 18 years on the x-axis, which is there, as accurately as we can, and we draw a line up to the straight line representing the clay soil, which clearly is this line here with the circles, which the key tells us. And then we draw a line across from the y-axis to where the line meets the line we've just drawn up, okay? So we draw a line up to there, and we draw a line across to the y-axis, and we read off this value here, which is 20. So an estimate for the height of this tree is 20 meters. A pine tree is growing in sandy soil. Work out an estimate for how much the height of this tree increases in a year. So we're looking for the rate of increase. If we look at the graph, 1 year is one small box, okay, across. So we need to work out, as we go across one small box, then how much are we going up by? Because if we look at the sandy soil, as we go across one box, we go up one box. That's how the gradient of the graph increases. So one small box upwards, in terms of the y-axis, represents 2 meters, because 10 meters is 5 boxes, okay? 5 small boxes is 10 meters, so one small box is 2 meters. So in other words, the height of the tree increases by 2 meters a year, because as we go across 1 year, we go up 2 meters for one small box on the graph, okay? Now part D, compare the rate of increase of the height of trees growing in clay soil with the rate of increase of the height of trees growing in sandy soil. In other words, in terms of the rate, we need to look at the gradients. So whenever we see this rate of increase, we're really looking at the gradients of the graph. Hopefully we can tell that with the sandy soil, we're going across one small box and up one small box. Whereas with the clay soil, we're going across two small boxes and up one. So the rate of increase of the sandy soil is twice the rate of increase of the clay soil. Okay? So the rate of increase of the sandy soil is double the rate of increase of the trees growing in the clay soil. Okay? And hopefully that's straightforward. Right, so let's look at question 3. So this is a survey question. Julian wants to find out whether people in his town like to buy food from the market. He wants to carry out a survey. He's going to ask people as they leave the market. This is not a good way of collecting information, and we're asked to give a reason why. Well, what this is looking for is the idea that if we're surveying people who are just leaving the market, then they're more likely to have bought food from the market, as opposed to just asking people randomly. So the sample isn't really fair. So in terms of the wording of the question, we're looking for something like surveying people who are leaving the market is unreliable because they are more likely to have bought food from the market. Okay? Now, the next part of the question says that Julian also wants to know what people think about the price of food from the market. He uses this question on a questionnaire. Food from the market is very cheap, do you agree? And we just have yes, no, or do not know as our 3 answer boxes. And we're asked to write down one thing wrong with this question. So the first thing to do here would be to look at the answer boxes. And clearly this is exhaustive. Yes, no, or do not know. So this is absolutely fine as our answer boxes. However, with the question, the problem lies with the wording. Okay? Because here with the word cheap, this doesn't necessarily mean the same thing to one person as it would to someone else. So the problem with the questionnaire is the wording in the question is not specific or quantified. And we're looking at the word cheap. Okay? This doesn't have a number, therefore we can't really say that cheap has a fixed value to one person as it would to another person. So this question doesn't clarify enough which box should be ticked. Okay? So with all these kinds of questions, the key really is to look at the answer boxes and then to look at the question, because there's always a problem with one of those things, perhaps both. Okay? So let's look at question 3 part C. Julian also wants to know how far people travel to buy food from the market. Design a suitable question for Julian to use on his questionnaire. So with this, a question could be, how far did you travel to get to the market? Okay, so that's an absolutely fine question to use. And our answer boxes, we're looking at perhaps 3 boxes would be fine for this question. So we draw them out. Let's move that across there. And we could have less than 5 miles, 5 to 15 miles, or more than 15 miles. Okay, and that would be the 2 marks. And the key here with answering this question is we have to have some kind of scale. And I've used miles here. And it doesn't matter what we use. We could use meters, we could use kilometers. It doesn't matter. That's not what the question is asking. We just need to make sure we do have a scale, and we also need to make sure that the boxes do not overlap. So for example, if we said 0 to 5 miles in this box and then 5 to 10 miles in this box, then we wouldn't know which box to tick because we have 5 miles in both. And if you've travelled 5 miles, then you could tick that box or that box. However, with this, we've made it so that the boxes do not overlap. Less than 5 miles, so that covers anything less than 5. 5 to 15 miles, and again, if it's 5 miles that you've travelled, you'd tick this box because this is only less than, and more than 15 miles for this box. So, as you can see, this works, okay? So we just need to make sure we have a question, at least 3 boxes, and a quantity that can be measurable. So moving on to question 4. The length of a field is 54 metres, correct to the nearest metre. Write down the least possible length of the field. So this question is testing our ability to round numbers, and it's relatively straightforward. All we need to recognise is that if it's rounded to the nearest metre, then the smallest value would be, that's meant to be a 5, 53.5. Okay, let's just write that out again. The smallest value would be 53.5, and we can round this up to 54, so this is the least possible length of the field, because if we had 53.4, that would round down. Anything less than this would round down. So this is the cut-off point. Now part B says write down the greatest possible length of the field. Now this is slightly different, because what you might think is 54.5 can round up, because usually we round this up to 55. However, we have to recognise that that's only a convention. It's only that we usually round numbers up. Clearly this number is directly in between 54 and 55. So actually we could just as well round down as we could round up. And it's perfectly acceptable to argue that, well, usually we round upwards, so I'm going to say this is 54.49 recurring. Okay, because this is technically the greatest value we can use that would still round down. And you'd definitely get the mark for putting that. However, in the mark schemes, you would see this value. So it's always worth putting 54.5, even though, yes, indeed, it does usually round up. That's the greatest length of the field, okay? So either of these are acceptable answers. So moving on to question 5, Kevin wants to get the ferry to Ireland. A ferry crossing costs £125 on Saturdays and £109 on Mondays. He has a voucher for 15% off on Mondays. He can go on Saturdays without using the voucher, or on Mondays using the voucher. What is the difference in the cost of the ferry crossing if Kevin goes on a Monday rather than on a Saturday? So, clearly the cost on a Saturday is fixed at £125, so I'm going to write S for Saturday, and that's fixed at £125. On a Monday, he has to use a voucher which is 15% off. It's £109 usually, so 15% off 100%, okay? This is how we would show our working, because again, looking at the marks allocated for the question, this is a 3 marker, so we need to show all stages of our working. 100% minus 15% equals 85%. Now if we convert this to a decimal, we simply do 85% divided by 100, and that will give us that number as a decimal, which is 0.85. And this is what we call our multiplier. So because this is a calculator exam, we simply multiply £109, which is the cost on a Monday. Again, apologies for my writing here. We multiply that by 0.85, and we type that into our calculator, and what we get when we do that is £92.65. So that's the cost on a Monday, and we're asked to find the difference in the cost of a ferry crossing if Kevin goes on a Monday rather than a Saturday. So a Saturday is £125, and a Monday is £92.65 using the voucher. So we simply do this calculation, we type that into our calculator, and what we get is £32.35, okay? So then we just write that down here in our answer box, if it will let me. Okay, £32.35. There we go. So hopefully that's relatively straightforward. With these questions, it's just about reading the question correctly, making sure that we understand exactly what's going on. As long as we recognise Saturday is a fixed price and on a Monday we're using the voucher, then the calculations hopefully are relatively straightforward, making sure we get our multiplier here. Right, so moving on to question 6. Stephen plays in a basketball team. The list shows the numbers of points Stephen scored in 15 games of basketball this year. Show that this information can be put into an ordered stem and leaf diagram. So we're just putting this into an ordinary stem and leaf diagram. And if you're not aware of what one of these is, I'm just going to show you now how we would structure this question. So to the left of this line, we always write the tens column. So clearly we have numbers that are single digit. We have numbers in the tens, the 20s as well, if we have a look there, and also the 30s column. And what we do is we then write out the second digit of each number in order of size. So first, looking at the single digit numbers, we have only 8 and 9. So we'd write 8 and 9, just like that. And what I would always suggest doing is putting a single line through the numbers that you've used so that you don't write them twice or don't miss any values. That just checks that we've got all the marks, okay? So just put one single line through, perhaps do that in pencil so that we can use this set of data again if needed for a second part of the question. So looking at the tens, we have 14 there, 18, 17, 18. So 14 is clearly the smallest, so we just write 4 because we've already wrote the 1 for the tens column, so we write 4. We then write 17, so 7, and we have two 18s. And then again, a single line through to show that we've done that. Moving on to the 20s, 26 there, 21, 20, another 21, 22, and another 22. So being very careful that we don't write these numbers twice. We have a 0, we have 20. We have two 21s. We have two 22s. Again, we don't need to write a comma between the values. However, you can choose to do so if you like, just to separate the numbers. I'm doing it so that it's clearer for you to see the numbers are separated. So 22, we've done that. We have 25, and we have 26. And again, a single line through the values we've used, and then finally onto the 30s. We have 30 and 33. So there we go. That's how you would draw out a stem and leaf diagram. Okay? And that's 3 marks there, so that's not too bad. Part B. Last year, the ratio of the number of games Stephen's team won to the number of games Stephen's teams did not win was 5-4. And last year, he played 36 games. Work out the number of games Stephen's team won last year. Okay. The ratio is 5-4. So if we add those together, we have a fraction out of 9. Okay? So, just make that clear that that's going to show up. There we go. We have a fraction out of 9, 5 plus 4, and 36 games were played. If we do 36 divided by 9, that gives us 4, okay? And now what we do with this number is we multiply this by the number that represents the games that the team won. And clearly this is a ratio of 1 to lost, so the 5 in this ratio represents the number of games won. 4 times 5, 20 games were won last year. Okay? So again, just to clarify, we add the numbers together in the ratio to get a fraction. We divide the number of games played, so the total, by that number, which is 36 divided by 9, which gave us 4. Then 4 times 5, because 5 is the number of games that were won in the ratio, and that gives us 20. Okay, so that's 2 marks again. Question 7. The table gives information about the numbers of badges gained by the younger girls in a guide group. So here's a table. Write down the mode. So this is just a case of understanding what the mode is, and what that is the highest value that occurs. So the highest occurring value. Looking in the frequency table, 8 clearly is the value that occurs the most, and this represents 1 badge. So we just write 1. Okay? So we look for the highest value in the frequency column, which represents 1 badge. Work out the mean number of badges gained by these girls. Right, with this question we have to follow a procedure which is the same each time, so take note here of how to answer this kind of question. So we extend the table. Okay, let's move that there. And here we add in the totals. So we write total, okay? And then we simply write in all of our totals here. So we do this by multiplying the number in this column by the number in the frequency column. 0 multiplied by 2 is 0. 1 multiplied by 8. 2 multiplied by 4. 3 multiplied by 3, and so on. Okay. And then here, at the very bottom, we do another total. Just an arrow there, which is the total of both the frequency and total column here. So if we add all the frequencies together, 2 plus 8 is 10, plus 4 is 14, 17, 22 and 25. And we'll write in a different colour for this column. 0 plus 8, 16, add 9, 25, plus 20 is 45 and plus 15 is 60. And again, this is a calculator paper, so don't try and work these out in your head when you could be using a calculator, because it's quite easy to make a mistake. And to work out the mean, we simply do 60 divided by 25. Okay, so it's the total in this column where we've multiplied the number of badges by the frequency, divided by the total of the frequency column. And this is always the same for every type of question. And that's 2.4. So the mean is 2.4. To make you aware of questions where we actually have numbers such as 1 to 4 or 2 to 6, for example, say we had in this column something like 2 to 6 instead of just 2 or 6, okay? We then use the midpoint of these values to multiply by the frequency. So here we'd use 4 and multiply that by the number in the frequency column, okay? So just to be aware of that if you are given one of those questions in the exam. Part C, there are 15 older girls in the guide group. The mean number of badges gained by these 15 older girls is 4.4. Work out the mean number of badges gained by all the girls in the guide group. So the mean here is 4.4 for the 15 girls. So if we multiply 4.4 by the total number of older girls, which is 15, again using the calculator, we get 66. And what we do then is we add this to the total we got here with the younger girls, because effectively what we've calculated here by doing the mean times 15 is the same as what we've calculated here, which is 60. So adding those together gives us a total and adding them together gives us 126. So that's our total. And then if we add together 15, because this is the frequency total, 15 plus the 25, which was the total frequency here, that's 40. So then we have a frequency total, and we have the total in effectively this column again. So 126 divided by 40, which is the same as what we did for part B. Again, we did 60 divided by 25. Our new total is 126, and our new frequency total is 40. So doing that gives us 3.15. So that's our answer to part C. Hopefully when you've seen that a few times, it will make more sense, but again, this is the same structure we would take for any kind of question in an exam. Okay guys, so let's move on to question 8. Right, so straight away this is a quality of written communication question, which is shown by the star there in the corner. Anya invests £40,000. She's going to invest in a scheme from either the building society or the bank. So there's the information for the building society and the bank. She wants to invest in a scheme that gives the most interest. What scheme should she invest in? 4 marks. So with the building society, we have 3% per annum compound interest there for 2 years, and 3% per annum just means per year, okay? So it's worth knowing that if you're not sure. Invest £40,000 in a bond that pays £2,550 interest at the end of 2 years. So again, 2 years, we have a fixed amount being paid at the end of that time. So with this being a written communication question, it's always worth structuring this in a way that is clear to the examiner what you're trying to do. So what I'd suggest is this kind of format. We have a building society and we have a bank, so a table like this would do. And for the building society, we need to work out the amount that Anya will have at the end of the 2 years. So we do this by typing into our calculator 40,000, which is the initial value, multiplied by 1.03, okay, to the power of 2 because it's 2 years. Okay, that's a 2. And just so you're sure exactly what I've done there, all I've done is calculated this 1.03 by doing 100% plus the percentage of interest, which is 3%. Now that's 103%. And to convert this to a decimal, similar to the previous question in the exam, which I believe was question 3 earlier on in the paper, we divided it by 100 to get this as a decimal, which gives us that 1.03. So with this being a written communication question, it's probably worth writing that out, but not necessarily required. This is what we must show: 40,000 times 1.03 to the power of 2, because it's 2 years, and it's always to the power of the amount of time that it's been invested for. Type that into the calculator. And we get this value here. Okay, £42,436. Okay, and we'll just add the pound sign there. Make sure you do include the pound sign, because with this being the 4-mark communication question, we need to include the context of the question. It's in pounds, so that just makes that clear. Now for the bank, which is clearly simpler than for the building society, because we simply do 40,000 plus 2,550 because it's a fixed amount interest at the end of 2 years. Type that into the calculator. That's £42,550. Again, using the sign there. It's meant to be a pound sign, okay? So that is the difference between the amounts that you will get at the end of 2 years. Clearly, this value here is greater than the building society, so you choose the bank. So Anya should invest in the bank, okay, the bank scheme. So we'll put a tick here, but just to make sure we've completed the question, then we need to look back here where it says gives the most interest. So we're looking at interest rates. So to find out the interest and the percentage increase, we simply do the amount we have at the end of the 2 years, and we divide that by the amount we initially invested. Type that into the calculator, and that gives us 1.03 1.0609. So that's the rate of increase. Okay. And we do the same for the bank. Divide that by 40,000. So we'll type that out. 42,550 divided by 40,000. And that gives us 1.06375. And again, clearly that demonstrates that the bank is the better option here because this is a higher value than this. So to complete the question, therefore, Anya should choose the bank scheme. And that is certainly enough for 4 marks. If you like, you can compare those two values directly in a sentence just to make it even clearer to the examiner, but this would certainly get you the 4 marks, okay? So again, take note of the written communication question there. And for question 9, the cumulative frequency graph gives information about the times in minutes of 140 girls revised for an exam. So there we are. Find an estimate of the median. So again, a question that is relatively standard. We look at the highest value on the cumulative frequency diagram. The highest value is 140. Don't be fooled by the 160 there. Although the graph goes up to 160, the actual line only goes up to 140. The median is always the middle value, so we halve 140. Half of 140 is 70. So let's find 70 here, which is going to be there. Draw a line across to the graph. Okay. Just make sure that's worked. There we go. And then we draw a line vertically down, which is there. And we read off the value. Again, in the exam, you'd be able to do that clearer than I can using this. Reading off that value, clearly it's going up in 2s. So we have 43 minutes, because it's in between 42 and 44. And again, you would probably be able to get it clearer than I can here using these tools, okay? So I'm going to say 43. There's usually some kind of range. If we check here on the mark scheme, just to see the exact value that they've used. They've used 43, so yeah, we're right there, okay? Go down to there. Right. So there we go. Find an estimate for the number of girls who revise for more than 30 minutes. So more than 30 minutes, well, by drawing a line up from 30 minutes, which is there, we'll do this in red, and again across to there. That looks to me to be exactly 50. And we're looking for greater than that 50, okay? Because it's greater than 30 minutes. The line goes up to 140, so 140 subtract 50 gives us the amount above the graph, which is just 90. Okay? So an estimate for the number of girls who revise for more than 30 minutes would be 90. That's question 9. So moving on to part C, which again, quality of written communication question for part 9. The box gives information about the times in minutes of 140 boys and how they revise for the same exam. The lower quartile for the times the girls revised is 22, and the upper quartile for the times the girls revised is 56 minutes. Compare the distribution of the times the girls revised with the distribution of the times the boys revised. So, with this question, 4 marks, we need to compare statistics directly, so I would always start with the median. So the median time for the girls is, and we said that was 43 minutes, okay? Because this is the one for the girls. 43 minutes. However, the median for the boys is, and we look here, this line in between the box plot gives us the median. That's 50, okay? 50 minutes. So it's higher at 50 minutes. So again, because of the fact that this is quality of written communication, we need to write this out in clear sentences. Next, I would compare the upper quartiles. So the upper quartile for the girls is 56 minutes, because that's stated in the question, just there, okay? Whereas for the boys, this is 70, okay? Because that's the line there we're looking at for the upper quartile for the boys. 70. The lower quartile for the girls is 22 minutes. This is higher for the boys at, and the lower quartile there is 40 minutes. Okay? So next let's compare the interquartile range. And the interquartile range is just the upper quartile, subtract the lower quartile. So for the girls, it's 56 minus 52. And we can abbreviate this to IQR, interquartile range, is 70 subtract 40. Sorry, that's for the boys. For the girls, it's just 56 minus 22, which is 34. Whereas for the boys, it is 70 subtract 40. Okay, which is 30. So the interquartile range for the girls is higher than the boys. You could write that out, but that should be fine. And just to make sure that this is complete, I would always compare the maximum and minimum values. So the maximum value for the boys is 80 minutes, and for the girls it's it's 90 minutes, okay? The maximum value on the graph there is 90 minutes. So for the girls, the maximum time is 90 minutes, whereas for the boys, it's 80 minutes. And again, I'm going to leave it there. You could then compare the minimum values as well, but that's plenty for the full marks. In fact, you could just have the interquartile range, the upper and lower quartile, and the median comparison, and that would be enough. But I would always add the maximum and minimum in as well. Okay, so that's question 9. So for question 10, part A, explain what is meant by a stratified sample. So all this is, and this is a standard answer, it's a sample where the proportion of the sample is relative to the population. in the population. So, in other words, the sample is representative of the population. So, that's 1 mark there, okay? The table gives some information about the number of people at a fitness centre one day. So, again, looking at the question, the sample is of 60 people. Work out the number of males aged 40 and over. That should be in the sample. So males aged 40 and over, we're looking at this value. So what we do, and again this is a standard question, we do 73 divided by, and we add all of these numbers together. So 73, make sure that's clear, it's going to show up, there we go, plus 25 plus 78 plus 45. So we add all those together and we type that into our calculator, and that gives us approximately 0.33. Leaving the full number in the calculator, we don't want to lose any accuracy. So it's approximately 0.33. And then we multiply that value on the calculator, which is 0.33 and then some other numbers, by the number in the sample, which is 60. And that gives us 19.81. 819 to be precise, and we're looking at the number of males aged 40 and over that should be in the sample. Now hopefully you're aware we can't have 19.819 of a person, so all we do here is we round this up to 20 because of course we can't have 0.819 of a person, so there should be 20 males in the sample aged 40 and over. Okay, so just to go through that again, we pick the number that we are told in the question, so the number of males aged 40 and over, so we pick this number, we divide that by all the numbers added together, and then we multiply the answer we get by the number in the sample, so 60 people in the stratified sample. Moving on to question 11. Here are some graphs that show relationships. A curve or line of best fit has been drawn on each graph. The equation of each graph is one of the equations in the following list. Give the equation of each graph. Right, okay. So we need to identify which one is which. Graph A increases, and clearly it's getting steeper at a large rate, so this is an exponential graph. And an exponential graph will always go through the point 0, 1. Always, okay? Because anything to the power of 0 is 1. For example, 3 to the power of 0 would be 1. 2 to the power of 0 is 1. Anything to the power of 0 is 1. So it will always go through 0, 1 on the y-axis. And it's increasing exponentially. So we need to look for an exponential function. This is linear. This is linear. This one here is a quadratic, as is this one. The only exponential graph is that one there. So for A, y equals 2 to the power x. Now for B, it's a straight line, so we can get rid of this one, and we've used this one, so it's either this graph here or this graph here, and it's a negative gradient sloping downwards, so we need a minus coefficient of x, so it must be this one because this is the only one with a minus coefficient of x. Now for C, we have an exponential, a quadratic graph. So we're looking at this one or this one. And the key point here is, if it's a U-shaped quadratic graph, then the coefficient of x squared is positive. And if it's an N-shaped graph, then the coefficient is negative. So negative and positive. Well, this is an N-shaped graph, so the coefficient of x squared needs to be negative. So it's not this one, it's this one here. So it's y equals 8x minus 2x squared. So we just need to be able to identify graphs for this question. Now for question 12. There are 8 counters in a box. The letter A is on 6 of the counters. The letter B is on 2 other counters. Sally takes at random a counter from the box. She keeps the counter. Okay, cross through the question there. Let's just do that again. So underlining this bit here. She keeps the counter. Then Tina takes at random a counter from the box. Complete the probability tree diagram. So, all we need to do here is, first of all, fill in this number here. Well, if the probability of getting A, the letter A, is 6 out of 8, then the probability of getting B, quite simply, is 2 out of 8. Because all probabilities add up to 1, linking back to the very first question. So, 6 out of 8 there, this must be 2 out of 8. Then we draw out, okay, let's make that clear. The tree for Tina. And you would join these lines together, but I can't do that on this program, so there we go. And there are 8 counters in the box originally, and again remember, when Sally's had her go, she keeps one of the counters. So the probabilities now are actually out of 7, because one of the counters has been kept and is not available for Tina to take. Now, if Sally chooses a counter with the letter A on it in her go, then there's one less counter with the letter A. So there's actually 5 now with the letter A. Okay? And again, it's out of 7 now. If Sally picks A in her go, then Tina could pick B, and there's still going to be 2 counters with the letter B. Again, now out of 7. Sally picks B first, and then A. Well, there's still going to be 6 A counters because the one that's been taken is a B. So there's still 6 out of 7 here. However, if she then takes a B, and Sally's taken a B in her go, there's only 1 out of 7 left with the letter B, okay? So that is the completed probability tree diagram, okay? And that's 3 marks. Part B, work out the probability that both Sally and Tina take out a counter with the letter A on it. So, with these questions, I always identify the word in the question, and the word is and. And if it's and, we multiply. If it's or, then we add. So because it's and, Sally and Tina take a counter with the letter A. Well, the probability of Sally taking a counter with the letter A is 6 out of 8. For Tina, it's 5 out of 7. So Sally and Tina is 6 out of 8 multiplied by 5 out of 7. 6 out of 8 multiplied by 5 out of 7, which is 30 out of 7 times 8, 56. Okay? Which is simplified down to 15 out of 28. Okay? So we could write that as 15 out of 28, or as a decimal, but I'm going to leave it in this form. Work out the probability that at least one counter with the letter A on it is taken. At least one. So, we could have A and A. We could have A and B, because that's at least one A. We could have B and A, but we can't have B and B, because there has to be at least one A. So we add together the fractions we get when we multiply each branch. So if we multiply 6 out of 8 by 5 out of 7, we get 15 out of 28, which is 30 out of 56. I'm going to leave it in that form for the purpose of this question. 6 out of 8 times 2 out of 7 is 12 out of 56. 2 out of 8 times 6 out of 7, 2 times 6 is 12, again out of 56. Now, we add together each of these values. 12 plus 12 is 24, add 30, that's 54. So we have 12 out of 56, add 12 out of 56, plus the probability of getting an A and an A, which is 30 out of 56. Which is 54. And again, we simplify this as much as we can. Well, 54 out of 56 can be simplified to 27 out of 28, dividing both the numerator and denominator by 2. Okay? And there we go. So just to check we've done everything right. And this is the way I would recommend you revising. Just go through a past paper, do each question in turn, and then check the mark scheme to check that we've done that right. So 54 out of 56, there we go, which is 27 out of 28 simplified. Again, they haven't simplified it here, but it's always worth doing because in some mark schemes they do want you to simplify your answer. So there we go, that's full marks. Okay, 30 out of 56 there. There we are. So that's question 12. Okay guys, now for the final question on the paper, which is question 13. The histogram shows some information about the areas of some farms. And again, we have frequency density on the y-axis and area in hectares on the x. And this will always be the case. Frequency density is always on the y-axis and we have some other variable, in this case area, on the x-axis. Now, almost always we'll be asked to find a scale for the y-axis because we're not given a scale here. And we do this using a simple formula, and this is worth learning, okay? Frequency is equal to frequency density multiplied by width of bar. By the width of bar I just mean the distance across the x-axis, okay? So the width. And we can rearrange this for frequency density by simply dividing through. Frequency divided by the width of bar is the frequency density. So we have to find out the frequency, which with some luck will be told in the question. There we go. 90 of the farms have an area of 10 hectares or less. So 90 is the number of farms, that's a frequency, with an area of 10 hectares or less. 10 hectares on this diagram is less than here. So it's this bar here we're looking at. And the area of the bar is the frequency. So the frequency is 90. We can use this now to calculate the frequency density. Using this formula here, we just divide by the width of the bar. 90 is the frequency, divided by the width of the bar, which is 0 to 10, which is 10. That's 9. So in other words, the height of this bar goes up to 9. So on the y-axis, that's going to be 9. And we have clearly 3 squares here. 1, 2, 3. 3 squares with 5 mini squares in between them, okay? So we can say that each bigger square must be represented by 3. because if this is 9 and this is 3 squares, 9 divided by 3 is 3. So 3, 6, 9. That's our scale. So this is going to be 12, adding 3 onto that, and the top bar is going to be 15. But we don't really need to add that on, okay? Next thing to work out would be how much each little square is worth in terms of value. Well, each bigger square is 3, and there's 5 mini squares for each big square. So 3 divided by 5 would give us 0.6. Okay, so just to state what we've worked out there, this is the frequency density of a small box. Okay, so each of these mini boxes is 0.6. So now what we can do is we can go on and work out the frequency represented by each bar, which is just the frequency density times the width of the bar. Well, the width of this second bar is 10 to 20, which is 10. Multiply that by the height, the frequency density. Well, here we've got 12, and each little box we've just worked out is 0.6. So we have 12.6 times by the width of the bar, which is 10, so 126. So that's 126. Now for this one, the width of the bar is 20 to 50, so it's 30. And the height is 3, 0.6, 4.2, 4.8. Multiply by the width of the bar, which we've just found out is 30. Type that into the calculator. That's 144, okay? And we do that for each bar. So with this one, 50 to 100, well that's a width of 50, and we have a height of 3 minus 0.6, which is 2.4, so 2.4 times the width, which we've just found out to be 50. And that's 120. So that. This one here, the width of the bar is 20. The height of the bar is just 3. So 20 times 3. That's 60. And finally here, with this bar, we have a width of 150 minus 120. It's 30. That's going to work. There we go. It's 30 times the height, which is 3 small bars, which is 1.8. Because it's 3 times 0.6. And we type that in and get 54. So there we go, we have the frequency represented by each bar. And we haven't even read the question yet, and we know that we've pretty much worked out what we need to know. And we're told to work out an estimate for the total number of arable farms. Okay, so 60% of the farms with an area of 100 hectares or less, so that's less than this point here, are arable farms. So we know that the total number of farms is all these frequencies added together, less than 100, so it's 120 plus this, plus this, plus this. So 90 plus 126 plus 144 plus 120. Type that into the calculator. That's 480. Okay. And we're looking at 60% of the farms that are arable. So we do 480 times by 0.6. Make sure that's right. There we go. And that's 288 arable farms that are less than 100 meters in area, sorry, hectares in area. Okay, now if we look at this part of the question, it says a half of the farms with an area of more than 100 hectares are arable farms. So now we're looking at more than 100 hectares, which is to the right of this point. And we can see that we have 60 plus 54. Farms in total, which is, again, making sure it's right by using the calculator, 114. And 50% of the farms we're looking at. So this value times 0.5 will give us 50% of the farms which are arable, and that value is going to be 57, yep. And then to finish the question off, we simply add together the two totals of arable farms. We have, just go back here, we have 288 plus the 57 we've just calculated, which gives us a total of 345 arable farms, and that is our answer. So just to be clear, 345. So to check that, we then go to the mark scheme. Let's have a look. And yeah, 345. Okay. So that is the paper completed. And if we go back to the very start of this, we can see that we actually get 60 marks and we're allowed 1 hour 15 minutes, which is as long as this video has lasted. So time should not be an issue with this exam. What I would suggest is that you go through this once more, just check out the questions you're less sure on, because hopefully this gives you an idea of what kind of things we're looking for on each question. And if you do have any questions, leave a comment at the end of the video. If you found it helpful, then please do leave a like. And I will see you in the next video, which is going to be on the non-calculator Edexcel paper for the higher tier. So thanks a lot, and I'll see you in the next lesson.